Space weather is something we experience because we live near a star, the Sun. Out in the countryside near Boston, Massachusetts, scientists at MIT's Haystack Observatory have been studying what happens to Earth's upper atmosphere when the Sun stirs up a little space weather.
In previous episodes of Space Weather FX, I've talked about what happens during solar outbursts, when material from the Sun impacts Earth's ionosphere and magnetosphere. In particular, when the ionosphere gets hit, we see immediate changes, from the appearance of aurorae over the poles to effects on communication signals, navigation systems, and power grids. The charged part of our atmosphere, the ionosphere, begins roughly 100 kilometers up, high enough that we could consider it the edge of space. However, this is just one part. The neutral part of the atmosphere, which we are much more familiar with, begins right here at the ground and goes up into the ionosphere itself. These two layers overlap. We live in the very lowest atmospheric layer, the troposphere. Between us and space are the stratosphere, the mesosphere, and the thermosphere, which overlaps the ionosphere. These aren't separate layers that are somehow magically divided from each other with very hard boundaries. Instead, the regions exchange material, motion, and energy with each other. Consider it like a big cake with layers that touch each other. The bottom level knows about the one above it. The middle layers know about regions above and below them. The top atmospheric regions, for example the ionosphere, know about the ones below them, but also know about the even higher altitude magnetosphere, the area of space controlled by Earth's magnetic field. And the magnetosphere knows about the solar wind, which fills the Sun-Earth system. In this way, all the layers of the atmosphere are coupled together, with the action taking place at the interfaces between each layer. For years, different groups of scientists focused on different pieces of the atmosphere. We here at Haystack Observatory specialize in the ionosphere. There are other groups who focus on the mesosphere and track such things as polar mesospheric clouds, studying their linkage to climate change. Other scientists look at the stratosphere or the troposphere and study the behavior and mechanisms particular to those regions. This effort has produced a vast quantity of knowledge about these individual atmospheric layers. But in our field, the science is going further and creating a more comprehensive understanding. Today, the frontier of learning for atmospheric scientists is the study of how all the atmospheric regions are coupled together. We know that if you give the atmosphere a push in one place, eventually something happens in another place. Space weather caused by solar disturbances is a good example of that. But as we learned with Larisa Goncharenko's study, something happening in the lower atmosphere can cause a form of space weather in the upper atmosphere. So perhaps one of the most amazing things we are learning about Earth's atmosphere is just how its various layers act, not separately, but together in what we call a coupled geospace system. There is still much to discover about the blanket of gas that surrounds our planet and its interactions with Earth's magnetic field, the planet's surface, and the interplanetary environment. We are working towards the day when scientists will put all of their models, observations, and knowledge about our dynamic atmosphere together in a grand unified picture. Here at Haystack Observatory, we continue to study the ionosphere and magnetosphere as our contribution to that big atmospheric picture.